if you can tell me which variables you would try to eliminate. So let's take a look just at number 1. So raise your hand when you can tell me which one you would eliminate. X or Y? Tiana, what would you say? X, yes, because those are already opposites, right? So those are going to cancel out quickly, and then you would solve for Y. We're not going to solve it, though. I know you could do that. So let's take a look at number 2. Number 2, what would you eliminate here? The 6's with the Y's, right? Those are opposites. Add those together, cancel those out. All right. So let's take a look at number 3. Add them together. I know. Edward, what would we cancel out here? X's or Y's? X's, yes. Good. They're already opposites. Get them out of there. All right, let's take a look at 4. Who can tell me what they would eliminate, the X's or the Y's, and how might you do that? Raise your hand when you've got an idea. Let's wait for some more hands. Hopefully we'll get some more hands. Which would you eliminate and how? Monty, which would you eliminate? The Y's, okay. And what would you do to eliminate those? Well, are they opposites right now as they are? No, they have the same sign. So what would you have to do to make them opposites? You're right. I probably would do the Y's too. But can you tell me what would I need to do first? Want to phone a friend? No, we're not going to subtract. Want to phone a friend? You pick somebody. Anybody? Okay. Allie? Multiply 2x, like this 2x, by everything on the top. I don't think so. Cristobal. Say that again. Multiply this by -2. Is that what you said? No, I don't think so. If I do that, I get -4x, and I'm going to get +6y. And that's not going to cancel out anything, I don't think. Or at least not what I'm thinking. Okay, hang on here. That's like, oh, really big. Who haven't I talked to? What? Multiply by 1. Is that going to change anything if I multiply by 1? No. Who haven't I talked to? Did I talk to you yet? I think I did, didn't I? Esme, what do I do? Yeah, multiply by -1. You were so close, Miss Ashley. Does it matter which one I would multiply? The top equation or the bottom? It doesn't matter because you're going to change the sign of one of them. I'm going to multiply by I'll multiply by the top one. Gosh, that's really big. So if I do that, I'm going to rewrite it below, and I was focused in on the Y's, okay? So right now they are both exactly the same. When I multiply by -1, it's going to change each of those terms signs. So negative 1 times 6x is negative 6x. Negative 1 times negative 3 is positive 3y. And negative 1 times 27 is negative 27. I put a line through that. And here we go. There is my two opposites, and those would cancel out. Okay? So I don't think that's what you said. I don't think that's what you guys said. But that's one way you could do it. All right. Let's check these last two out. And by the way, you could always do the x or the y. It's just that one of them is probably going to take a lot more work. So 2x plus 7y equals 1 and x plus 5y equals 2. Which would you eliminate and how would you do that? I see hands of people I've already talked to. Antonia, what would you do? Yeah, I would probably do that too. Multiply the bottom by negative 2. That gives you negative 2x. Negative 2 times 5 is minus 10y, and 2 times negative 2 is negative 4. Add them together. I'm going to put a line through here. And here you've got your two opposites. So those would cancel out. Very nice. Very nice. And the last one. 4x plus 2y equals negative 14. 5x plus 3y equals negative 17. This one you have to probably go big or go home. If you know, you know. So 5 is the largest coefficient, but 4 cannot go into 5. 3 is the larger of the two coefficients, but 2 can't go into 3. So you're probably going to have to multiply each equation by something. So as I look, I would probably try to get rid of the y's. When you think of 2 and 3, what's the least common multiple, or the number that they both would divide into? 6. So let's change the top one to be a 6y. Let's change the bottom one to be a negative 6y. So what would I need to multiply this whole top equation by to get 6y? 3. Yes. Everything up here would have to be multiplied by 3 times 3. Okay. And what about for the bottom? If I go from 3 to negative 6, I have to multiply there by how much? No. I want to go from 3 to negative 6. So 3 times what gives me negative 6? Yeah, negative 2. Multiply by negative 2. So on top, 3 times 4, that would be 12x plus 6y equals negative 42. I'm going to put a line through that. And for the bottom one, negative 2 times 5 is negative 10x. Negative 2 times 3 gives me the negative 6y, and negative 2 times negative 17 is positive 34. Put a line through that, and here are my two opposites that have opposite signs, 6y, negative 6y. Those are what would cancel out. Okay? Isn't it just too bad we can't just do that for all the time instead of solving for x and y? All right, let's turn the page and let's go to some word problems. Okay? All right. So we are using elimination still, but we have to come up with these equations. All right? So listen and follow along. Amy and Corey are planning a party for approximately 75 people. Okay? 75 people. A pizza that feeds 5 people costs $10. 5 people, and it costs $10. A pan of pasta feeds 12 people, come on, and costs $26. They have $160 to spend. How many pizzas and pans of pasta will they need to purchase? Okay, this question often tells you what your variables are going to be. Okay, so let's say, do you guys like using X and Y? It's always weird if they use different variables, isn't it? No? Okay. How many pizzas? Let's let X be the number of pizzas. Ugh. X is number of pizzas, because that's what we're looking for. How many pizzas? And Y is going to be the number of pans of pasta. Now, there are two main things going on here. Okay? We have money involved, and we have amounts. Okay? So I'm going to have one equation be my money equation. Money, money, money. So anything with money is going to go in the money equation. Anything that has to do with a number or amount is going to go in the other equation. Okay? So think about and look at the money. It says a pizza that feeds 5 people costs $10. $10 is definitely money. So let's put $10 down here to begin with. And that is for a pizza. Well, if it's $10 for every pizza, do we know how many pizzas we are going to need right now? No, but we know we're leaving it as X. So for each of those pizzas, it's going to cost $10. So that total is going to be 10 times X. 10 times X. $10 times the number of pizzas we get, we could figure that out. We also have pans of pasta that cost $26. So $26. And we don't know exactly how many pans of pasta, but we've got a variable for that. And that variable is Y. So for each pan of pasta, it costs $26. So for Y number of pans, it's going to be 26 times Y. And we are talking about money. How much total can they spend? 160. That's like your total. Your total is usually at the end of the equation. So this is equal to $160. Now, the only thing I'm missing is some kind of operation between the 10x and the 26y. If we're talking about total, what operation would that use? Addition. So let's put a big old plus sign right there. So that's the money equation, okay? The other one talks about amounts, okay? So we know we have approximately how many people coming? 75. Where do you think that 75 is going to go in your equation? At the beginning, at the middle, or at the end? At the end. That's your total. That's how many you are accounting for. So 75 is going to go at the end. I'm even going to put the equal sign in there. And pizzas, how many, that's my amount or number, how many can eat from one pizza? 5. And how many pizzas do we have that we're planning on? We don't know exactly, but we are calling it how many pizzas? 5x. That's right. So X number of pizzas and 5 people can eat from it. So 5 times X tells me how many people can have that pizza. All right. Then it says we have 12 people can eat a pan of pasta. So I'm going to put 12 over here. We don't know exactly how many pans of pasta I need yet, but we've got the Y, so that's going to be 12 times Y. And again, the only thing I don't have here is my operator in between, and that is going to be addition, plus. So for this particular one, we don't need to solve it, but if I were to write this out, I would say 10x plus 26y is equal to 160. And I would say 5x plus 12y is equal to 75. Now, as you look at those, do you see any graph nearby? No, so we're not going to graph it to figure it out. Do you see where we could easily isolate a variable and use substitution? No. So that leaves elimination. What would you probably do to eliminate one of these variables? Multiply this bottom one by -2. Multiply this by -2. And that would cancel out your x's. Okay? We're not going to solve it all the way through, but that's what you would do. Does that make sense to everybody? Omar, come on, stay with me. All right, let's go to the next one. So, a quilt maker sews both large and small quilts. A large quilt requires 8 yards of fabric, while the small quilt requires 3 yards of fabric. If she uses a total of 90 yards of fabric to make 15 quilts, how many of each size did she make? There's your question. How many of each size did she make? Okay? So I'm going to say we have large quilts and we have small quilts. Let's say L is equal to, what should we make L equal to? Number of large quilts. And let's use S for the number of small quilts. Now, let's take a look back in my equation. A large quilt requires 8 yards of fabric. Small quilts require 3 yards of fabric. She's using a total of 90 yards to make 15 quilts. So there are 2 things going on here. Can you identify, I guess I won't go that way. 2 things that we're talking about here. Look at the totals. We got 90 yards total and 15 quilts. So one of the equations is talking about, say it again. Yeah, the yards of quilts. Okay, yards of quilts. So this one is talking about yards of quilts. And what's the other one talking about? Are yards of fabric. I should say fabric. Yards of fabric. And this one is talking about total quilts, right? Total quilts. All right, let's talk about the yards of fabric first. Okay, so yards of fabric. It says she uses a total of 90 yards. Where's that 90 going to go, Omar? Where's 90 going to go in my equation? At the beginning, the middle, the end. If it's the total, the end, right? So 90 goes back here. This is yards of fabric. We also have 3 yards for a small quilt, 8 yards for a large quilt. So let's do the large. It's 8 yards. Do we know how many large quilts we can make? No, that's my variable, but I'm going to make L number of them. So that's going to be 8 times L plus, I know it takes 3 yards of fabric for a small one. So that is 3 times S, and that equals 90. So that whole equation talks about the number of yards of fabric that we need. The other side talks about the total number of quilts. And how many total quilts is she going to make? 15. Put that at the end. That's your total. Now, those total quilts, how many different quilt sizes is she making? Just 2, right? Small and large. Large is L. So I put plus 15. That's wrong. Equals 15. Of those quilts, of those 15 quilts, how many are going to be large quilts? No. 8 is how many yards of fabric it takes to make a large quilt. But how many large quilts will I have? L is your number of large quilts. So it's going to be L. We don't have to multiply anything there. L is the number that we need to make that are large sized. Okay? So how many small quilts are we going to have out of those 15? S number. And if you combine the number of large quilts with the number of small quilts, add them together, that gives you 15. So these are my 2 equations. I'm going to write them below. 8L plus 3S is equal to 90. And L plus S is equal to 15. All right, let's go. We got one more. See if we can get this one in. And we're not going to worry about solving them today. Probably going to work on solving at least the bottom 2 tomorrow. All right, Sam adopted 2 kittens from the shelter. 2 kittens. Sterling was 8 ounces when they got him. He is gaining 1 ounce each week. So he was 8 ounces, and he's gaining 1 ounce each week. Stella is 12 ounces when they got her. She's gaining a half an ounce each week. When will the kittens weigh the same? When will the kittens weigh the same? And how much will they weigh? All right. When will the kittens weigh the same? How much will they weigh? All right. Any ideas on this one about how to set this up? There should be 2 things we're talking about, and if you look at your questions, that's kind of what we're talking about. When will the kittens weigh the same? And how much will they weigh? Let's do the weight one first. So we're going to call this our weight equation. All right. Weight equation. gaining 1 pound. No, I don't think that's what we're going to look for here. I think what we're going to do, and I know that was the bell, I think we're going to have a Stirling equation, and we're going to have a Stella equation. Okay? When will the kittens weigh the same? So Sterling, hang on. I know. Sterling is 8 ounces. He's gaining 1 ounce each week. So at the beginning, he was 8 ounces. That is going to be 8, which I wanted to do in blue. And he's gaining 1 ounce every week. Do we know how many weeks? No. So we're going to say 1 times x. And that is going to equal y, which is how much he's going to weigh. Stella started out at 12 ounces, and she is gaining 1/2 ounce each week. We don't know how many weeks that is, and that's going to be equal to her total weight. And we will finish the rest of this tomorrow. Also, homework number 3 is due tomorrow. We will review tomorrow after we finish this up. I have a review packet. We'll get started on that. Test is Tuesday. Okay? Test is Tuesday.